In this video, I'm going to show you another shortcut that we can use to avoid having to do the problems as the three-step problems that I've talked about in other videos. I'm going to use even and odd properties to change all of these negative angles into positive angles. Because as of right now, all of these would have to be done with the three-step method because none of these angles, these negative angles, are in our chart that we've made. So here's how the even and odd properties work. It turns out that cosine and its reciprocal, secant, are examples of even functions. So I'm going to go ahead and note that cosine one and then the secant one down here, these are both things we'd call even functions. And what that means is it doesn't matter if the angle is negative or not. The cosine of negative pi over 6 is the same exact thing as the cosine of positive pi over 6. So for cosine, you can always just kind of ignore that negative sign on the problem. Same is true for the reciprocal, the secant. You can ignore any negative angle that you have to work with because they're even functions, they work out to be the same. Well, that's a really good shortcut for the cosine problem back up top because cosine of pi over 6, well, I can just look up in my chart. The cosine of pi over 6 is just square root of 3 over 2. It doesn't matter if I do cosine of negative pi over 6 or cosine of positive pi over 6. They're both going to come out to be the same thing, positive square root of 3 over 2. Alright, so the secant one, again, secant is also an even function. So the secant of negative 210 degrees is the same thing as the secant of positive 210 degrees. So let's just go ahead and worry about that. I can ignore the negative. Well, it's not as great of a shortcut on this one because 210 is still not in the chart. So I would have to do this as a three-step problem. So I'll show you that. If you've watched the other videos, you've probably seen this a ton of times by now. 210 degrees is going to be there in quadrant 3. I need to sketch it and find the reference angle. My reference angle ends up being 30 because it takes 30 degrees past the x-axis. So really what I want to find out is what the secant of 30 degrees is. That is in the chart. Secant of 30 degrees works out to be 2. Square root of 3 over 3, but I need to possibly adjust my sign, S-I-G-N sign, because that might be positive or negative depending on what quadrant we ended up in. So that's where these letters came into play. Oops, that's not the right letter. A-S-T-C. We are in the T quadrant, or the third quadrant, which tells us that tangent would be positive, but anything else would be negative. Well, we didn't do tangent, we did a secant, so I have to throw a negative sign on this answer. So my final answer ends up to be negative 2 square root of 3 over 3. And again, it didn't matter if I did the secant of negative 210 or the secant of positive 210, it's always going to work out to be negative. That's how even functions work. And cosine is the only one with its reciprocal that's even. Well, if it's not even, then that must mean the other ones are odd functions. So sines and tangents, as well as their reciprocals, are examples of odd functions. And in these functions, the negative sign does matter. The way it works is, I can still get rid of the negative angle, but the answer is going to end up being the opposite of what it would have been. So I'm going to rewrite this problem as the negative sine of 45 degrees or the opposite sine of 45 degrees. So for odd functions, you kind of take that negative and swing it out to the front of the problem, and you can ignore it in there. So I'm going to look up the sine of 45 degrees. It's still a shortcut, because watch. I know what the sine of 45 degrees is according to my chart. That's the square root of 2 over 2. But because I was dealing with a negative angle in an odd function, I need to make sure the answer is opposite of what it would have been. So the cosine of, or the sine of negative 45 degrees is negative square root of 2 over 2. Okay? Because it was an odd function, it ends up being opposite what it would have been. Alright, so for our last one then, cosecant, which is the reciprocal of sine. So again, we're dealing with an odd function. I'm going to pull that negative sign out front. So I'm going to end up getting the opposite answer that I would have had if this was positive. So let me rewrite this as the negative or opposite cosecant of 3 pi over 2. 3 pi over 2 is a quadrantal angle. I should have that in the chart. So I'm going to look up what the cosecant of 3 pi over 2 is, and according to my chart, that's negative 1. But remember, since we're dealing with an odd function, I'm going to end up the opposite of what I would have got. So this time I actually end up with a positive 1. Sine and tangent are odd functions. Your answer will be opposite if you're dealing with negative angles. Cosine and its reciprocal are even functions, meaning the negative sign doesn't matter. You're going to end up with what you would have gotten if that angle was positive anyway.